Alright, today's lesson we're going to talk about solving quadratic equations by taking square roots. Just a quick reminder that the quadratic function ax squared plus bx plus cs equals 0 is written in standard form. And there are 4 different ways that we can solve quadratic functions. We can solve them by factoring, we can solve them by completing the square, we can solve them by doing the quadratic function, and we can solve by taking square roots. And that's what we're going to do today. So in the first definition we need to look at here is the square root. And to remember, a number s is the square root of t if s squared equals t. So an example of that would be if we have 3 squared equals 9. And I also have that negative 3 squared is equal to 9. And so that means that if I take the square root of 9 is equal to 3 or negative 3. Okay, the first example we're going to look at here is x squared minus 9 equals 40. My first step to do is I need to isolate the square term. So I need to get this x squared term by itself. So the first thing I'm going to do here is I'm going to add 9 to both sides. They cancel out on the left. I'm left with x squared equals 49. Alright, so my next step would be is to find the square root of both sides. Okay, so to do that, I take the square root of x squared, and I take the square root of 49. The square root of x squared is x, and the square root of 49 is positive 7 and negative 7, or you can write it as plus or minus 7. And we refer to these as the solution to the quadratic equation. We call them the roots. Excuse me. Of quadratic equation. We also call them the x-intercepts. So these are 3 terms that relate to the equation, the solutions to the equation. We call them solutions, roots, or intercepts. Okay, the second example I'm going to look at again is 3x squared plus 7 equals 430. So again, we have to isolate the square term. So the square term is being multiplied by 3, and then I'm adding 7. So remember, when we solve equations, you undo the last thing that's being done. So I'm going to subtract 7 from both sides. They cancel out here on the left. I'm left with 3x squared. 43 minus 7 is 36. So now I need to get rid of the 3, and I do that by dividing both sides by 3. And I'm left with x squared equals 12. Alright, so my next step here would be to take the square root of both sides. And if I do that, take the square root of x squared, the square root of 12, the square root of x squared is x, and this would be plus or minus the square root of 12. Alright, now we need to simplify the square root of 12, and if we remember that the perfect squares that go into that would be plus or minus the square root of 4 times 3. 4 is a perfect square, so the answer here will be x equals 2 plus or minus the square root. Sorry, it's going to be x equals plus or minus 2 square root of 3. Okay. Alright, our third example we'll look at here is x squared plus 9x equals negative 16. Again, we need to isolate the squared term, so I'm going to subtract 9 from both sides, cancel out on the left. I'm left with x squared equals negative 25. Okay, so again, take the square root of both sides, x squared, square root of negative 25, square root of x squared is x, and then this gives me plus or minus the square root of negative 25. Now if we think back and remember from our simplifying radical portion of this unit, we know we cannot have this negative 25 in the radical. So we need to break that down into the imaginary unit, negative 1, square root of negative 1 times 25, and then replace that square root of negative 1 with the imaginary unit I. Okay, and then square root of 25 is 5, so this becomes x equals plus or minus 5i. Okay. Example 4, 2x squared plus 5 equals negative 31. Again, have to isolate this variable, so it means I'm going to subtract 5 from both sides. cancels out here. I have 2x squared, negative 31 and negative 5. They're both negative, so I'm going to add them and keep the sign, so I get negative 36. I'm going to get rid of the 2 by division, and I have x squared equals negative 18. Take the square root of both sides. I have x squared equals the square root of negative 18. The square root of x squared is x. And this is going to plus or minus the square root of negative 18. Again, I cannot have that negative in the radical, so we need to change this to x equals plus or minus the square root of negative 1 times the square root of 18. Keep in mind the square root of negative 1 is I, and this is radical 18. And then we need to simplify radical 18 to its perfect square factors, and that will be 9 times 2, and the square root of 9 is 3, so this becomes plus or minus 3i radical 2. Again, keep in mind that these guys here are always going to be referred to as roots of the equations, solutions of the equations, and they're also x-intercepts. That's what they're called all the time. Alright, to summarize, to solve quadratic equations by square roots, you're going to use this when you're missing the bx term, when you just have it in the form of ax squared plus c, no bx term. And to do that, you're going to isolate the square term, take the square roots of both sides, solve, and then remember, if there's a negative left in the radical, you've got to bring it out and use I. Be sure to do the completion ticket after the video, and make sure you bring any questions and your notes to class. Remember, notes and videos are both graded activities. Thanks, and have a good night. See you tomorrow.